Yes, hello everyone. You are welcome to another video session of Python for All. In this video, we will talk about control flow in Python. Our emphasis will be on if statements, while loops, and for loops. First, what is control flow in Python? Control flow in Python is the order in which codes are executed. It is regulated by conditional statements, loops, and function calls. Let's start with conditional statements. Conditional statements allow the program to make decisions based on the value of a variable or expression. The most common conditional statements in Python are if. This statement executes a block of code if the condition is true. Elif. This statement is used to add additional conditions to an if statement. Else, this statement executes a block of code if the condition in the if or elif statements is false. In other words, if the condition of the if statement is true, the block of codes is executed. Likewise, if the elif condition is true, the block of codes are executed. But if either of these two statements is false, the else statement is executed. Let's look at this example. In example 1 here, first we define a global variable x, which is equal to 10, and then we pass a conditional that if x is greater than 5, print, here I'm using f string, print x is greater than 5. In other words, print the number itself, which is x, or the variable itself, which is x, is greater than 5. Else, print the variable or the number is not greater than 5. Now, let's move to the next cell and execute this code and see what happens. In this case, I'm using 2. Let's start with 10 because in the example stated, we've got 10, right? So now x is 10. Let's execute this cell. You see, it prints out that 10 is greater than 5. Because the condition in the if statement is what? True. That's why it prints 10 is greater than 5. The else statement is not executed, right? Let's change this condition again and put 2 and run again and see what happens. In this case, x is actually not greater than 5, which is less than 2. So the if condition or if statement is false. So what will get executed is the else condition or the else statement. If I run this cell again, what do we have? 2 is not greater than 5. The x in that f string there is referring to the variable you have specified, which is the output, which you are the global variable precisely. So you can see which is true. So see now that the if statement is not executed because it is false. What gets executed is the else statement. So that's how the if, elif, else conditional statement works. First, the code checks if the if statement is true, it is executed. If it is false, it checks if the elif, if you have an elif statement, if it is true. If it is false, then it goes down to the last statement, which is the else, and executes the else statement. That's why you remember when we talked about PEP 8, it was stated categorically there that do not just use the if statement, but use the if and complete it with the else statement. Don't say if and then you end it. Then no, it should be if, and when that condition fails, what happens? That is what will be executed in the else statement. With that, we'll move straight to the next control flow, which are loops. Loops allow the program to execute a block of code repeatedly. In other words, loops are used for iterative operation or for iterative purposes. What it means is that the block of code will run for a number of times, and oftentimes it runs infinitely. We'll see that very shortly. The most common loops in Python are: the first one is a for loop. This loop executes a block of code a specified number of times, in other words, for a finite number of times. While the second is the while loop. The while loop executes a block of code as long as the condition is true. So the while loop executes a block of code infinitely. In other words, for as long as the condition is true. If the condition is false, it breaks out of the while loop. Let's look at these examples. Example 2. Here I'm looping in the range of numbers starting from 0 until 9, because if you see a range of 10, it stops at a number one less than the specified stopping um, point or stopping value. So let's see. Now I say for I in range 10, okay, print I. In other words, for I in this range of numbers, print I. I can decide to modify this print to use an S string and say print I equals, and then I'll put I and close this S string. The first I there is what is simply a string literal, while the second I is the variable itself that we are printing out, okay, which is in the range of 10. You see here, Python perfectly understands this by avoiding conflict in the namespace. The I, which is a string literal, and the I, which is the variable. That's exactly what we meant when we talked about namespace in Python. So let's run this cell and see what happens. What we have, it prints the first, so it runs the block of code repeatedly until the specified number. We specified it for a number of times, for 10 number of times. So for I in range 10, it prints the first number value 0, 1, 2, 3 until 9. If you count, we have a total of 10 elements in of printed out on our screen, okay, from 0 to 9. Now let's move to another example, example 3. Here we'll look at the factorial function, which we have talked about earlier. So here we have our function definition factorial n if n is equal to 0. If you can see the condition, if the index is 0, or if the number is 0, not index please. If the number is 0, return 1, because 0 factorial is actually 1. Else, if the number is not 0. So if that first statement is true, then you should return 1. Else, if that statement is false, then execute the return statement, which is n times factorial of n minus 1. Here we have called factorial recursively. And afterwards, outside the function block, let's print factorial of 5. In other words, we want to see what the factorial of 5 is. I can modify this to use an S string again and say factorial of 5, which is a string, equals to, I put this in brace bracket and then close the apostrophe. I run this code, it tells you factorial of 5 is equal to 120. I can equally modify this and use this factorial symbol, also go back this way. It appears as string, that was 5 factorial, which is mathematically how it is represented. If I run the cell again, what do I have? 5 to factorial equals 120. So the last is the while loop. Here, a while loop in Python is a control flow statement that allows codes to be executed repeatedly based on a given Boolean condition. And that Boolean condition is if the condition is always true, the loop will run forever. That's why it is called an infinite loop. Now, oftentimes it's encouraged or you are encouraged not to use the while loop except when it is absolutely necessary. Otherwise, use the for loop because it can actually run infinitely, you know, and that's a very big problem. So next, you see here, you can use the break statement to terminate a loop early. So if you don't want your loop to run infinitely, then you put in another condition, which is the break statement. What the break statement does is to get out of the loop, to break out of the loop when a certain condition is met. Now, remember the while loop runs as long as the condition is always true. So to break out, you need to set the condition to false and to be able to break out of the while loop. You can use the continue statement to skip the current iteration of the loop and go to the next one. So you see, we're still going to talk about the break and the continue statement. So what the break statement does is that the break statement takes you out of the loop entirely, but the continue statement rather returns you back. It's just like you are going back up. It's a loop. You are looking through, but when you encounter continue, the code, you know, gets out and go back and starts the looping again. But break, no, takes you entirely out of the loop. But continue returns you back to the start of what? Of the loop. So I think I will take another video session to talk about these statements. Break, continue, yield, statements to and illustrate that with examples. So let's see this next example, which is 4. In this code snippet here, first I initialize I as 1, and then while I is less than or equal to 10, print I. And after printing I, what next will you do inside the while loop block? Increment I by 1. So in other words, if I is less than 10, print it. Okay, let me modify this. Okay, we'll modify it in the main code itself. Okay, we'll modify that in the main code itself. So let's go back to this cell to look at the code. So I is equal to 1. So it's like initializing I, the start point is 1. So why I is less than 10, if it is true, okay, for the first one loop is 1 is less than is true, print what? Print I. See here, I'll put in our next string, our F string, which I love to do a lot. I'll say I is equal to I, and I'll close the F string. So print it. After printing it, the next operation to do before going back to check again the condition is to increase I by 1. So I becomes 1 plus 1, 2. He checks it. Yes, 2 is less than 10. He prints it. Add 1 to it, 3. 3 is less than, increment until you get to condition where it's less than. Let's see what the result we get when we print this. We run this cell. Do you see it? 1, 2, 3, 4, 5 until 10. If this condition was set to I less than, if this condition was set to I less than 10, let's say when I is less than 10, let's see what happens and increment. We run this cell again. What do we have? We have it 1 until 9 because 9 is less than 10. Because it's less than or equal to, okay, by the time it gets to 9 and it increments to 10 and it checks the condition, is 10 less than 10? No, it breaks out of the while code. The while loop ends there. So let's look at example 5. In this example, I'm looping through a range of 10, of course 0 until 9 for I in range 10, and right inside that loop, in other words, I have multiple loops, okay, for I in range 10, for J in range 10, right? And there's a condition there. If, okay, if I is what? Is even, and if J is odd. This modulo operator, when I percentage symbol 2 is modulo operator, when it is equal to 0, it means there is no remainder. So, and when there's no remainder, when you divide the number with 2 and there's no remainder, it means it is even. When there's a remainder of 1, it means it is odd. So we're just saying that if I is even and J is odd, okay, simply append a tuple of I and J to an empty list result. then break. Okay, then next break. So let's see what this gives us print result. Then I'll come back to explain the uh, control flow of this code. So we come here and we run this cell. Can you see the result we have? 0, 1, 2, 1, 4, 1. You can see the tuple until 8, 1. Now notice that the J does not go beyond 1. The idea is that here we have multiple loop. As long as one of the condition, it loops, first of all, it loops through all I from 0 until 9. Okay, and then pick all the even numbers. You can see that 0, 2, 8, 0, 2, 4, 6, 8. And then after that, looping through that, it now gets down into the inner loop to loop through all through the J. But because of that break statement, it will only loop through all the J for uh for for only one for twice, two times. Okay, for when it for J in return looks through when it is 0, and then evaluate by the next looking while one is looking through the next time, which is 1, of course. 2 J divided by J modulo 2 operator equals 1. That condition is true. And mind you, when he's looking through this, looking through them using the AND, so both conditions must be met. So where those conditions are not met, where they are false, what do you expect? You expect the break statement. So that break takes you entirely out of the two loops, and that's why you see only one was appended for J, while the result for I was 0, 2, 4, 6, and 8. Now let's further illustrate this using the continue statement. Let's see the result here. Same condition, same code, looping through the range of 10, J in the range of 10. Then the condition if I is even and J is odd, and okay, both conditions must be true before you append that result and then continue. If you run this code snippets, you see the continue statement, instead of breaking out of the full loop, takes us back up. So that's why it prints 0, 1. It goes to 0, 2, 0, 3, 0, 5. So you look for first case 0, I is 0. Check it. Is it even? Of course, it to return 0. The remainder returns 0. So, and it looks through all the J's. That's why you can see all the odd number of J's from 1 until 9. Right? Then it goes back to the next. The continue statement instead of takes it back to the outer loop for I again. The next I is what? Is 1, which is false. It runs through again. So the continue statement will always take you back to the top, the outer loop, which is a for I in return. So that's the flow. So continue statement, takes you back to the beginning of what? Of the loop. As sometimes you want to ask the question, where does this find application? You will see where we use them. There are instances where we use them. It is based on the algorithm of your code that will determine when you use the break and the continue statement. But they are very, very helpful and handy when you have such situations to deal with. Now, in this next example here, I want to do something. You notice that in the first code in cell 8, when we apply the break statement, it took us totally out of the two loops. But here I want to show you how you can break out of the inner loop without breaking out of the outer loop. Okay, so that when you apply your break statement, it takes you out of the inner loop if the condition is false, and then you still retain your outer loop, and until that same condition is false before you can break out of the outer loop. Otherwise, if in the first place when we use the break statement, once the inner loop condition is false, it breaks you out of both the inner loop and the outer loop. So here, we use what we call a flag. Can use any name to represent it. So we set flag to false, and then we start The same way for I in ring 10, for J in ring 10. If J is 2 and I is 0, just set any condition you feel like. Okay. If these conditions are true, then the flag should be true. Then break. Okay. Break. Then once you get out of the inner loop, you apply flag again. You call the flag, if flag. In this case, we don't say if flag is false again. No, we just say if flag, because in the inner loop we have already set flag to true. The flag must be true. So the flag is already true. Okay, once that flag is true, then what it means is that, oh, once this condition is state the condition is false and the flag is set to true, it enables you to break out of that inner loop. But again, you say if flag. In other words, if flag now break. So like, we can run this code in this cell. If you run it, and then you already have it in our namespace, print results. You see, we achieve the same results of using same results. Okay, so we achieve same uh, results. So it gives us, result is gives us this. So this is just a way. Okay, I'm printing the previous results. Okay, so this is just a way of breaking out of the inner loop without breaking totally out of both loop. That's just what I've shown you in this code, in this code here. Okay, the next is here using a flag variable. Now we are still using this flag variable, but in this last example we are now uh using the flag variable as an input argument to a function. So here we define a function, break loops, and the input is flag. First, we initialize I to 1, j to 1. Here I want to use a while loop. So I say y I is less than or equal to 10, y j is less than or equal to 10, print I comma j. Okay, once I printed I comma j, increment I, in other words, increment j, in other words, increase j by 1. Okay, and again, why the loop is going on? Okay, one, because it will check the when it picks the first j 0 less than 10 or equal to 10 true, it will print. It needs to go again. The loop, is this like a circle, it keeps looping. So to loop, to go to the next loop, it needs to increase j by 1, and increase j by 1, it becomes 1. It checks the condition 2. When it now gets to 10, what do you expect? At 10, 10 is less than, yes, true. Okay, so the while loop terminates. As soon as that while loop terminates, what next I want him to do, still that's the inner while loop this time around. What I want him to do is that increment I by 1 and set j to 1 in the outer while loop. Because in this case now, you will notice that I need to, when it looks at the first I 0, it will run all the inner loop for j, then come back to the second I value, which is should be 1. But this time around, when it's coming back, it's already increased by 1, and then set j to 1. So that is what the inner while loop will do. Why the outer while loop what will see I being incremented by 1 and then j being assigned to 1. Now, if flag break, in other words, if flag is true, break. If flag is false, break. So, but this if condition here with the break will break you out of both while loops. Out of both. If you don't want to break out of both while loops, you will use this example here by first of all setting the flag to false, and then you have two break statements, one for the inner loop, one for the outer loop. So let's run this and see what we have. So I run this cell. I already have my function in my namespace. Let's print the function break loops when flag is false. If you run this, you see it prints 1 until 10. It goes back to start 2 until 10, 3 until 10. You can see for all j, loop through the range until 10. 1 goes to at same way. It loops through 1 until 10. So for every corresponding I, you have all j's. For I is equal to 1, you have j is equal to 1, I is 1, j is 2, I is 1, j is 3, I is 1, j is 4. Continue like that until you exhaust the j. Then the I is incremented by 1, and then the outer loop runs again with all the j's. Okay, when you set j to 1, it means you reinitialize j to 1, because in the outside both while loops, you have I and j to be local variables inside the function. So but while you are inside the loop, because you have already started calling j, you need to reinitialize j to 1 for to increment I in the outer while loop. It may look a little bit confusing, but with practice, you would really get to follow what I'm doing here. But in the real sense, for practical purposes, it is often advisable not to write while loops, just to use for loops, because of the infinite um, processing running of the while loop. Okay. So now let's go back and run the last example, which is break loops when the flag is true. If I run this cell, you see the loop would only look true for I equals 1 and corresponding j 1 to 10. Once it meets that condition, because the flag is true, because you have said break, if the flag is set to true, it breaks totally out of both loops. So with this, we have come to the end of this video. If you have any question, please leave it in the comment section. Also, we will take more examples in our next practical coding, live coding section, when I will go live, and then you have opportunity to ask your questions. We'll take more examples, take more practical applications of the control flow, and see how we use them in writing our codes. Okay, so having said that, I will leave a link for the download of this notebook in the description section, so that if you need to download it and use it, you can easily get it from get it through the link. So with this, we have come to the end of this video. Like this video, share this video, and if you have not subscribed to my channel, please do so, and do not forget to hit the notification bell to get notified of my new upload. Until then, I will see you in my next video. Bye.